Welcome to the chapter, Vehicle Chassis and Suspension Architecture. Welcome to the lesson, Effects of Rolling Resistance and Tires on Range. In the context of this topic, we will look at how SimCenter a MESM can use to study the effects of different tire sizes and thus coefficient of rolling resistance on battery capacity and vehicle drive range. We will create a study manager where a matrix of different coefficient of rolling resistances will be used to observe its effect on vehicle driving range. For the sake of simplicity, the tire size will be kept constant with an assumption that its coefficient of rolling resistance changes in each iteration. Global parameters can be set for desired tire and wheel sizes, including values for coefficient of rolling resistance. The table lists all the vehicle parameters, including wheel, tire parameters. Tire rolling resistance is defined as the force required to maintain the forward movement of a tire in a straight line at a constant speed. Tire rolling resistance coefficient is calculated by dividing the measured rolling resistance force by the tire size's prescribed load during the test. Tire rolling resistance force is calculated in pounds or kilograms of resistance. Comparing the rolling resistance force provides a direct way to compare tires of the same size, as well as an accurate means of comparing different tire sizes to one another. Comparing rolling resistance coefficient allows comparing tires within a single size and does not allow comparing tires of different size. Larger tires generally have a lower rolling resistance coefficient than smaller tires but generate higher rolling resistance forces at a given speed. In order to observe the effects of coefficient of rolling resistance on the driving range, all the rest of the vehicle parameters will be fixed and will be used as baseline parameters. These baseline parameters are shown in the table above. The parameters are for battery size and electric motor size. We will also select a baseline value for coefficient of rolling resistance for the vehicle against which the changes can be compared. We will look at two iterations of coefficient of rolling resistance acting on the vehicle as shown above apart from the baseline set to study the effects of coefficient of rolling resistance on battery range. It is important to set up the vehicle parameters properly before we can run any analysis. Open the file, Electric Vehicle Modeling a MESM Model, from the Lab Files folder. We are going to change first the cycle definition here for NEDC, that's the first step. Then go to the battery or to the other one and go here to the Presizing tool. To specify the battery that is on the presentation and NCAC. Then those three parameters were specified. Just show that those are the three target parameters, a voltage target of 396 and so forth, and then apply. Then they open circuit voltage data, and geometric resistance, and all that data files will be changed. You say overwrite and they will be changed automatically here. And for those, the data files that are changed for the battery. Then the next step is, we're going to study the parameters and submodels. You can select multiple items and then you can go to global parameters and specifying a tire size, and also you need to change the maximum motor torque 300. Then all you need to do is specify the wheel tire and the tire width. The tire size is 215/60 R17. And then the coefficient of rolling resistance, which is set for 0.01. We are going to study this parameter. So, what we can do is either you can say OK here and go to simulation. And then go to Study Manager. You can delete those parameters that we are not going to study them right now. And then all you need to do is to go to Studies. Open the Global Parameters window and drag and drop the parameter that you want to study. In this case is the coefficient of rolling resistance. Just drag and drop it here. Apply OK. And then you can specify the sets that you want to study. In this case it's 0.01 and 0.02. It will be displayed on the results, but all you need to do is to just add another one. And then start run from here. You need to change the simulation time to 1200. Now you can see the results within the target range as per the presentation. We will see how to create cross results plot for electric vehicle modeling. Open Study Manager and make sure you have specified the sets that you want to study. In this case it's 0.01 and 0.02 and target range is 300. And then go to Cross Result tab and select Result Set Selection window, click OK. Then go to Post Processing tab, under Simulation Results select Estimated Range and remove Cross Variable Range. And then select Estimated Range, remove Secondary Range Target. Then select Plot Manager from Tools tab, move Range Target upwards and apply OK. Then change plot type, select Add Plot to System window, click New, enter Range Target Cross Results and apply OK. As seen from the plot, our target range is 300 kilometers. Our baseline tire size is 215/60 R17. Iteration 1 has a baseline coefficient of rolling resistance value of 0.01. We see that with this load, the range target if achieved. This indicates that the tire size and the coefficient of rolling resistance selection is sufficient for achieving range target. In iteration 2, coefficient of rolling resistance value is increased to 0.02. The driving range with this value is reduced to 270 km, which is below our range target. This signifies that the coefficient of rolling resistance value affects the driving range negatively by increasing the resistance the vehicle must overcome. A different tire selection must be made to achieve our targets. With this we end our lesson on effects of rolling resistance and tires on range. Thanks.